Hello, class 12th students. In the last lectures, we are talking about in the previous video, you have seen the some integrations of the exercise 7.1. So, some questions are left. Today, in this lecture, we will discuss that questions. Questions start from the 11, question number 11. We have done the question number up to 10. So, see, this question number 11 says what? X cube plus 5x square minus 4, and you see in the denominator we have x square is there, and this is the numerator. We have to do the integration. So first of all, I would like to remove this denominators parts are there. So separate the numerators, the terms are there, separate the terms. So we say this integration becomes what? I will write down just below it. This integration becomes x cube upon x square plus 5x square upon x square plus, not plus, this is a minus sign, minus 4 upon x square, and the integrations we want to do. Separate the terms in the numerators. If we further simplify this one, you see this one, it becomes what? X cube upon x square, this x square goes upper side, the power becomes, now you can say only x dx, this x square cancel out, the second one comes out 5 dx, and third one you see minus 4 integration of 1 upon x square dx. Now, better, I will write down this thing in the left side. So what the integration becomes now, x dx plus 5 times integration of dx minus 4, and this 1 upon x square. Take power of x numerator, x is to minus 2 dx. Now apply the formula. Since in the last formula, say what is the formula we will use here, x dx. The formula, integration of x raised to n dx equal to what? X power n, x raised to n plus 1 divided by n plus 1. Use this formula. X dx becomes what? X power 1 plus 1, x power 1 plus 1 divided by 1 plus 1 plus, say 1 is there, constant is there, the station of constant will be only x minus 4. You see, x power minus 2, it means x raised to minus 2 plus 1 divided by minus 2 plus 1. So this comes out x square by 2 plus some constant c plus 5x minus 4 x raised to minus 1 divided by minus 1. Now, plus some constant c. Now, you see, further we want to simplify that part. If I want to write down its correctly, x square by 2 plus 5x minus 4. See this minus 1, you see this minus 1 and this minus sign. So this minus minus becomes plus 4. See, x raised to minus 1 can be written as 1 upon x. So it is, you can say this is 4 into 1 upon x plus some constant c. This will be the answer. This is the answer of the question. Now we want to do the question number. Next questions. Question number 12. X cube plus 3x plus 4 divided by root x dx. See this question. X cube plus 3x plus 4 divided by root x. Root x in the denominators are there. We want to do the, can be written as what? X raised to half. But I see the root x can be written as x raised to half. Is the same thing. So I will write down here and separate the terms. X cube upon x half dx plus integration 3 constant taken outside x upon x raised to half dx plus in 4 times integration 1 upon x raised to half dx. So in the next line, what I'm saying that here, I say this x power half should be taken upper side. I take this denominator terms into the numerator terms. So it becomes x 3 into x ki power minus half dx plus 3 times integration x into, you can say this x into x raised to minus half plus 4 times integration x raised to minus half dx. So combine these two terms. So what we say, we are getting x 3 minus half. 3 minus half will come out x raised to 5 by 2. 3 minus half. I will do right in here. 3 minus half will be equal to what? Taking 2 LCM, 6 minus 1, it will come out 5 by 2. So x raised to 5 by 2 dx plus 3 times, you see, 1 and minus half, 1 minus half, taking 2 LCM, 2 minus 1, you see 1 by 2. Integration x raised to half dx plus 4 times, same thing, x raised to minus half dx. Now, we want to do the integration of this part. So integration of this part, we use the formula. The formula is what? Since the formula is x raised to n dx will be, x raised to n plus 1 divided by n plus 1 plus some constant c. We use this formula to find out the integration. So we see that what we are getting, x raised to 5 by 2 plus 1 divided by 5 by 2 plus 1 plus 3 times x raised to half plus 1 divided by half plus 1 plus 4 times x raised to minus half plus 1 divided by minus half plus 1 plus some constant c. Okay. Simplify this one. You know how to add this one. 5 by 2 plus 1 will be equal to x raised to 7 by 2 upon, you can say here, 7 by 2 plus 3 times x raised to 3 by 2 upon, you say, 3 by 2 plus 4 times x raised to half divided by half plus some constant c. Now, we combine all these terms, simplify this one further. If you simplify this, all these terms are that. You see this one. So you write down here 7 by 2 is there, can be written as 2 by 7 x raised to 7 by 2 power plus 3. 3 cancel out. You see this this 3 and this 3 will be cancel out. So it becomes 2 goes to upper side, 2 x raised to 3 by 2 plus, you see, 4 and 2 multiplied 8 x raised to half plus some constant c. This is the answer. Now we are coming on the next questions. So we done this question number 12. Now we want to discuss this now, question number 13. You see in this question number 13, the denominator we have a term this x minus 1. Okay. And first of all, we have to want to remove this algebraic terms from the denominator. So you see in this numerator, this is a third order polynomial is there. I will do the factor of this part. So this x minus 1 will be cancelled out. Let's see how can we do it. Okay, see this one. I do the first of all, I will do the, because I want to remove the, do the this one, this part, numerator is there, do the factor of that part. And how we can do the factors of this part, let's say x cube minus x square plus x minus 1. I take in this part uh, x square common in the first two terms. You see. So what we are getting? X square common. So this becomes x minus 1. Here in these two terms, we take the plus 1 common. Now, in the next line, I say x, we are taking these two terms, this terms and this term. X minus 1 common. This factor is common. So now what we are getting? X square plus 1. So this is the factor is there. So what this integration becomes? See, this is the integration is there. Now this integration becomes, write down the factor of this part, x minus 1 divide, this is the x square plus 1 and x minus 1 dx. See, this x minus 1 factor and this x minus 1 factor are common in numerator and denominator. So this integration can be written as x square plus 1 dx. And now we separate this one. Integration of x square dx plus integration of dx. You know, x square dx will comes out, you know, x2 plus 1, or you can say x cube by 3 plus x plus some constant c. Now, we want to do this question number 14. You see in this question number 14, these terms are given root x. And you know very well how we are writing the root x, dealing with the root x are there. Root x means x raised to half. So we put this integrations here. Integration 1 minus x root x dx can be written as 1 minus x raised to half dx. This can be written as, you say, open the bracket, we are getting x raised to half dx minus integration x into x raised to half dx. This can be written as, you see this, what we are saying that you see integration x raised to half dx minus integration x raised to 3 by 2 1 plus half 3 by 2 dx. So we say, now taking the integrations, we are getting x raised to 3 by 2 divided by 3 by 2 minus x raised to 5 by 2 divided 5 by 2 plus some constant c. If you further simplify these terms, or you write down here better, the first term 3 by 2 can be written as 2 by 3 x to power 3 by 2 minus 2 by 5 x raised to 5 by 2 plus some constant c. So this is the answer of this question. Now, we want to do this question number 15. See this question number 15, uh, again the root x is there. Multiply this root x by the value. You see, this can be written as a root x is there, x raised to half into 3x square plus 2x plus 3 dx. Open the, separate the terms, we are getting integration 3 is a constant taken outside, x raised to half x square dx plus 2 constant taken outside, x raised to half into x dx plus 3 taken outside, x raised to half dx. Simplify this one, we are getting 3 integration half plus 2 becomes 5 by 2. 5 by 2. You see, half plus 2. Taking 2 as a LCM, it becomes 1 plus 4. This becomes 5 by 2 dx plus 2 times half plus 1 becomes x 3 by 2 dx. You know this one. 1 plus half. Taking 2 LCM, so 2 plus 1 comes out 3 by 2. Plus 3 times addition of x raised to half dx. Now, we are taking the integration. We adding the 1 in every number. We will like to add the numbers. You see this one. Equal to 3 it becomes x power 5 by 2 plus 1 divided by same thing 5 by 2 plus 1 plus 2 times x raised to 3 by 2 plus 1 divided by 3 by 2 plus 1 plus 3 times x raised to 1 by 2 plus 1 divided by 1 by 2 plus 1 plus some constant c. So now, if you simplify this one and add the terms, what you are getting? 3 x raised to 5 by 2 plus 1 comes out, you see this one, 7 by 2, x raised to 7 by 2 divided by 7 by 2 plus 2 times x raised to 5 by 2 divided by 5 by 2 plus 3 times x raised to 3 by 2 divided by 3 by 2 plus some constant c. Now, combine all the terms. We are combining the terms are there. What we are getting? If we combine the terms are there, and you see this one, 3 and this 7, and this 2 is there, goes to those upper side. You see this 2 goes upper side. 3 into 2 becomes 6. X raised to 7 by 2. This 7 is here, 6 by 7. Plus 2 is here, this 2 is here, 2 and 2, this 2 and 2 become the 4 upon 5, x raised to 5 by 2. Plus, you see, this 3 and this 3 will be cancelled out, and this 2 goes to upper side. You see 2 x raised to 3 by 2 plus some constant c. This is the answer of this question. Now, after this 15, we will do this question number 16. What this question says, integration of 2x minus 3 cos x plus e raised to x dx. Here is a combination of, you can say, algebra, trigonometry, and the exponential function. So separate all the three terms, and then we start solving the question. I say first, separate the terms. The first term will be 2 times integration x dx minus 3 kicking constant cos x dx plus integration e raised to x dx. Say, now we know the formula. Integration of x will be, that will comes out 2 times x square by 2 minus cos x has a formula 3 times, this becomes the sin x, and e raised to x remain as e raised to x plus some constant c. So 2 and 2 this cancel out, this 2 and this 2 cancel out. So it will come, answer is x square minus 3 sin x plus e raised to x plus some constant c. This is the answer. Now, 16 is done, and now we want to do this question number 17. So this question number 17 we are talking. Say in this question number 17, what is given to you? This is a algebraic function, trigonometric function, and again the algebraic functions are there. Separate all the one. We separate all the three. 1, 2 is a constant taken outside. Integration of x square dx minus 3 taken outside constant sin x variable dx plus 5 constant taken outside root x. Root x can be written as x raised to half, as you have seen all the times. So now taking integrations, 2 into x square, 2 plus 1, 2 plus 1 comes out 3, so x raised to 3 upon 3 minus 3. Sin x will be, addition of sin x will be minus cos x plus 5 times x raised to half means x raised to 3 by 2 divided by 3 by 2 plus some constant c. So now you see 2 by 3 x cube minus into minus, minus this minus and this minus, you see this minus and this minus multiplied become the plus 3 cos x. And you see this is 5 and 2 multiplied, this 2 and 5 are multiplied making the 10 by 3 x raised to 3 by 2 plus some constant c. So this is the answer. Now question number 18. See, question number 18 says integration of sec x multiplied by sec x plus tan x into dx. Trigonometric terms are there, and these factors are there. By formula, we know the formulas. We know the integration of sec square x dx. This is a formula that it is equal to tan x plus c, and also this formula sec x tan x dx equal to sec x plus c. So we know these two formulas are there, and we want to use this two formula here. So this integration becomes what? Open the bracket. If we open this bracket, first I write on the integration questions. Integration of sec x, we have to find out sec x plus tan x dx. Okay. Open this one. If we separate this one, what we are seeing right on the next line better. So I say this one integration of sec square x, open the bracket, dx plus integration of sec x tan x dx. All right. Now, integration of sec square x dx, we know the formula. This is the formula. Sec square x dx will be equal to tan x plus c. So it becomes tan x plus integration of sec x tan x. Again, we know this formula. Sec x tan x dx equal to sec x plus c. Sec x plus c. This is the answer of this question. Now, after 18, we do this question number 19. You see this question number 19. Trigonometric functions are given. Sec square x upon cos square x dx. See, we want to remove this denominators are there first, basically want to say. This sec square x is there, this cos square x is there. So I would like to remove these terms are there and convert into sine and cos. So it will be equal to what? Since we know sec x equal to 1 upon cos x, reciprocal, and we know cosec x equal to 1 upon sin x. We use this one. Sec x can be written as, we see, 1 upon cos x whole square divided by cosec x can be written as 1 upon sin x whole square dx. This can be written as, you see this one, cos square x and the sin square x. So we see that right down here, the 1 upon cos square x into 1 into goes to upper side sine square x dx. Now we can simplify this one. You see this as one. We can simplify further. So we write down here integration sine square x upon cos square x dx. Can be written as, you see, combine of sin x upon cos x whole square dx. That sin x upon cos x can be written as, tan x whole square dx. Now, this in question becomes what? This question becomes a simple identity of tan square x dx. But we don't know the tan square x dx formulas are there. So, we do the formula here again. Again, we say tan square x dx. We know, since we know 1 plus tan square a equal to sec square a. We will apply this formula in this integration. So now this tan square x becomes what? Integration of sec square x minus 1 dx. So separate these terms. If we separate these terms are there, you see this one. This becomes integration of sec square x dx minus integration of dx. Sec square x dx will be tan x, and 1 will comes out, we say, minus x plus c. This is the answer of this question. So now the next question we see. Okay, question number 20. 2 minus 3 sin x upon cos square x integration dx. Okay. In the numerator we have a 2 minus 3 sin x, and in denominator we have cos square x. So in this question, first we separate the terms. We see that we separate the terms, what we are getting. If I separate both the terms, so it becomes 2 constant taken outside, 1 upon cos square x minus 3 constant outside, dx also here, no doubt, dx. 3 sin x upon cos square x dx. So this can be written as by how we say that here, 2 constant cos square x means we know reciprocal of this one, sec square x integration of sec square x dx minus 3 times can be written as, we say here, sin x upon cos x into 1 upon cos x dx. You say here 2 times integration of sec square x dx minus 3 times integration of sin x upon cos x will be, you see, tan x, and cos x is 1 upon cos x means sec x dx. Now, taking the integration, we know the integration of sec square x is tan x, or we say 2 times tan x by formula, minus 3 tan x sec x. This formula is there. A formula. This is the formula. This is the formula of sec x. Sec x plus c. And now we say sec square x, the formula, the integration formula give the tan x answer. So this is the answer. So now we would like to discuss the another question. Question number, we say we have done up to 20, now 21. The antiderivative of root x plus 1 upon root x equal to a, b, c, d. These four options are given to you. Equal to which one? See, we have to just find out the integration here basically, not options are important to us. Now we are taking the integrations, you know, this is root x are there. So better you write down here the x half plus 1 upon x raised to half dx. Can be written as, separate the terms, x raised to half dx. And this say this part, second part, we take this one into the numerator side. So it becomes x raised to minus half dx. Okay. Now, taking the integrations, we are getting x raised to 3 by 2 upon 3 by 2 plus, add 1, you know, if you add the 1, minus 1 plus 1 will be equal to what? Taking 2 LCM, minus 1 plus 2, it comes out 1 by 2. X raised to half divided by half dx. So simplify this one. So if you simplify this part, how you write down this answer in a correct way, you see this 2 will take in upper side. The four terms are that 2 by 3 x raised to 3 by 2 plus 2 times x raised to half dx, not dx. Also because we are doing this integration already, so this is not the dx here, plus some constant c, and also here we say some constant c. So now question number 22. If function is a fx equal to, this one is given to you, if d by dx of fx equal to 4x cube minus 3 upon x raised to 4, such that f2 equal to 0, then fx is. Okay. A function is given, the derivative of the function is given. You see this one first, you condition this one. The dy dx of fx is given, taking integration both the sides. If we take the integration both the side, dy dx of fx equal to integration of 4x cube minus 3 upon x raised to 4 dx. Okay. Now, see, integration and differentiation are opposite process to each other. So they are both are cancel out. So this becomes fx becomes, you see, separate the terms, we are getting 4 times integration of x cube dx minus 3 times integration of, taking this x raised to 4 upper side in the numerator, x raised to minus 4 dx. Okay, implies that fx will be equal to 4 times, taking integration, x raised to 4 upon 4 minus 3 x raised to, we add 1. If you add the 1, minus 4 plus 1 becomes minus 3. So it becomes minus 3 divided by minus 3 plus some constant c. See, now implies that, simplify this part, the function of fx will comes out, this 4 and this 4 will be cancelled out. So it becomes x raised to 4 And if you see this minus 3 and minus 3 will be cancelled out. This first minus sign and minus sign. This two minus sign will be cancelled out, become the plus, and 3 and 3 will also cancel out. So it becomes x raised to minus 3 plus some constant c. Now, in the question you see this value, some value is given for x. f2 equal to 0. It means when x equal to 2, the function of fx will be 0. So now we are putting here x equal to 2, the function will be 0. So we say f, we put the x equal to 2, it becomes 2 raised to 4 plus 2 raised to minus 3 plus c, and this will become, we say, 0. It's basically we are doing this all the things to find out this value of constant c. So you can see that will be 2 raised to 4 means 16, and 2 raised to minus 3 means plus 1 by 8 plus some constant c equal to 0. So implies that what? C equal to, you see, minus 16 minus 1 by 8. Taking 8 LCM, you see 16 8 ja, 16 8 ja, 128 or not 128. Yeah, 128 minus 128, and this minus 1, and we see the value of c will comes out minus 129 upon 8. So see, the value of c is now known to us. So we put this value of c in this equation number, you can say 1. If we put the value of c, so the function becomes what? So the function becomes, you see here, I write down the function here, answer, fx will be equal to x raised to 4 plus x raised to minus 3 minus 1 upon 129 upon 8. This is the answer. And also you see this one, the answer of this question. So this one comes out answer of this question. The fourth, first one is the answer. Okay. So now this is the end of the chapter. I hope you enjoy this chapter. Now watch my other chapters on the integrations and mathematics of class 12th, 11th, and 10th and JEE. Thank you very much.